Hello everyone, this is Vishnu and from Institute of Aeronautical Engineering. For image processing subject TikTok, I have selected road traffic conditions classification based on multi-level filtering of image content using convolutional neural networks. So let's get started. So what basically is a convolutional neural network? In short, they're called as CNNs. So these are those kind of networks which take images as their inputs and provides will provide a required type of data as the output where maximum it's a text, so it's a string. So there will be images and there will be images of same size which are being pre-processed, and with the help and while building the network itself we will define how many output layers will be there. So that's basically a CNN. That's basically for every neural network we will define the input, uh, sorry, and the number of outputs that we are expecting. So so CNN comprises of these main terms, which is a kernel, stride, padding, and activation function. So a kernel is something which will be of size n by n, and this kernel will go through the whole image and will capture the and will perform a operation, or there will be a function which can take out the average of all the pixel values and provide a, and create one single pixel. Let's say there's a 3 by 3 kernel size, so for every 9 pixels which are there in one area will get a one single value. So it's 9 is to 1. For every 9 pixel values there will be a one value that is generated with the help of this kernel. Other can be with um, eliminating negative values, because images doesn't consist of negative values. It The range is from 0 to 255, so it will be in this range. So that's what basically a kernel is. So stride is nothing but how many pixels to be considered as one. So let's say we have stride of 2, then it will consider 2 pixels as 1 pixel. So that's stride. Padding. So coming to padding, it's something which will add a boundary to the image, the current image, such that we won't miss out any features which are present in the at the end or at the edge of the image. So for those particular reasons, we will use padding. We'll have padding to the images, and then we will start a kernel to parse through the all the pixel values. So padding is basically will be a zero value, and value will be of value 0. So it won't affect anything on the kernel. Like it won't influence the pixel values which are there at the edge. So that's padding and activation functions. There are two most used functions, which is one is ReLU and softmax. ReLU stands for rectified linear unit, and softmax. So ReLU range does start from -1 to 1, where in ReLU uh, from -1 to 0 there will be no value, or there is no uh, output, or it's basically 0. So for the values which are between -1 to 0, the values are defaulted to 0, and when it's from 0 to 1, the values will range from 0 to 1 with the floating values like 0.1, 0.12, 0.99, and so on. So 1 being white and 0 being black. So that is rectified linear unit. And coming to softmax, it is a activation function, which will be end, at the very end of the CNN model. Like it's the output layer of the neural network, the whole neural network. If you build a whole uh, not that example. Um, for Yeah, at the end we will use softmax for the output layer. So why do we need a system to detect road traffic conditions? So the problem statement was that, or the case was, the system for classification of traffic condition was built for determining traffic control strategies. So manually we have implemented a new strategy uh, on roads so as to divert the traffic. Uh, with the help of this system, we can detect whether we did a good job or we took a right decision in diverting the traffic in the way they did or they have planned. So for that evaluation process, they have built this system so that they can analyze and detect how much, I mean, the traffic uh, on roads and so on. So systematic assignment of the volume of traffic enables to take appropriate decisions to direct traffic streams. And this will also act as a source of information for the authorities to take right decisions and uh, implement them in real life. So for these reasons, this system has been designed for evaluation and for the data, and it also accesses the data source, or we can say that it's supportive, not supportive. Okay, it helps the authorities to figure out a way to take decisions, way to figure out a strategy. This plays a vital role because it's providing us with the end information. So how basically, I mean, how this how this will work. So there are four images where with no one, I mean no cars on it, a few cars, a little bit dense and more dense, like it's a traffic jam. So uh, these kind of input images are sent as inputs, and the convolution neural network will predict whether the it's of LOS 1, 2, 3 or 4. So LOS being the level of service, uh, it LOS 1 results in no traffic, LOS 2 results in very light traffic, LOS 3 mild, and LOS 4 um, traffic jam. So as we can see that these input images will be of size m by n, and these all images should be of same size. And if we can see, um, the with the help of level of service, we can state that there are four output nodes or neurons, we can say, which will be fired based on the input data. So there are only four nodes at the output end of the neural network. Moving on, the neural network that they have used. So they have taken a input of 128 by 128 pixel image size, and with the help of that they have converted that 128 by 128 into 30 by 30 with the help of uh, kernel. As I've said earlier, if we take a 3 by 3 kernel, then we will be converting 9 pixels from the input. uh, Here this is the 128 by 128 kernel, and every if we as per the previous example, if we consider a 3 by 3 pixel image, then we will be converting these 9 pixels into one single pixel over here. So in this example, they took a 9 by 9 kernel with stride of 4. So 4 as 1 and 9, 36. So yeah, 3681s. Uh, those number of pixels are converted into 1 over here, and thus resulting in a 30 by 30 or 128 by 30, which would result in 22.66. 22.66. I'm not sure. It doesn't work actually with the help of floating values, because it only works with um, non-floating values. So yeah, so we have constructed a 30 by 30 image with 128 by 128 image pixel size, and from 30 by 30 we are going to 14 by 14, then 12 by 12, 5 by 5, 5 by 5, and 2 by 2. And we have four classes, which are nothing but the four states, which is LOS 1, 2, 3, and 4. So over here, C1 is nothing but the convolution 1, uh, S2 I'm not sure, C3, C5, convolution 3, convolution 5. Or the sample, this can maybe this is a sample of after max pooling. Well, max pooling will remove the negative values which are attained from this convolution. Max pooling will make sure that it will remove all the negative values and provide the, well, max pooling, it will have ReLU in it as the activation function, and thus eliminating all the negative values and providing us with a value which doesn't have image which doesn't have negative values. So yeah, thank you.